Anyway, I just summarize about the second section for the whole course. That mainly started from the BMS up to the infrastructure, so that you can see which is the important component for my course before you work with the quiz, right? So firstly, the second portion, we try to look into the key point for the course, and also hybrid vehicle, and also the charger. That's the key thing we cover in here. So the number area we think will be important. Say the cell equalization for BMS, that's important area, and you must understand properly. We also learn briefly about the charging type and also the standards. Of course, infrastructure, we just talked about them, is really important. We're also looking into battery swapping technology and also dynamic charging, and briefly go through the charging, the payment method. And also opportunity charging is important area. And the city planning, the vehicle development, how you relate to city planning. Finally, looking into the power issue for EV in the city. You see, for the cell equalization we've been discussing, we think passive method is the basic thing to examine, to talk about this kind of the cell balancing. So passive method basically to use a resistor to help the discharge. But the thing is, this kind of passive discharge only for peak voltage protection rather than real kind of the balancing. We cannot use passive method to balance the cell at any time. We only balance the cell at the final voltage. But active balancing is different. Active balancing, we do the sensor to sense the voltage all the time, and then we can energize the balancing at some suitable moment. Whenever we need it, we can do balancing much earlier than the end of voltage. Usually, an AMC battery with 4.2 volt would be the maximum voltage. You can balance them in 3.7, 3.8, whatever. Rather than wait until 4.2 will be too late. We don't have sufficient time, sufficient power to balance. You see, when we balance it, I think we've done some calculation, the balancing may pick up high current. We don't want that. We want a balancing circuit will be light current, light power, with smaller resistors, smaller MOSFET. So that means if you can balance the cell much earlier than 4.2 volt, then it's our beneficial application. So the technique we use two techniques. But both which are using inductor method, another would be switch capacitor method, using capacitor to balance the cell. There's two major methods for active balance anyway. So the detail you can refer to my full looks. Same thing about the charger. We learn about level 1 charger, which usually refer to 120 volt AC. First time when we develop a charger based on this one. Because this method firstly developed in US or Japan, so that's why we call it level 1 charger. But for other countries, like European country, or most Asian country, we use 200, 220, maybe 240 volt. So that means once we use this method, even though single phase, we still call them level 2 charger. So that means level 2 charger refer to 240 volt range. May not be 240, 240, maybe 200, 220, 240, this voltage. Or single phase or three phase. The power level usually about 11 kW or less than that, or maybe usually less than 16 kilowatt. Higher than that, we usually go for the so-called the high power charging system. The level 3 charger usually, because high power, we usually tend to use DC charging. DC charging will be usually more than 50 kilowatt. But we look through many of the DC charging in the market, the highest one could be up to 400 kW, but usually most of them will be 250 anyway. But so that's the standard. Then we can also see that there's a many standard like the North American standard, GB, that means the China standard, and also IEC standard in Europe or US, and also Japanese standard, which is so-called the China one. So the major standard we use, the number, the code, you can refer to my detailed lecture notes. For the infrastructure, I think besides in the lecture notes we talk about, I think the focus area will be the charging station. Yeah, how do we design the charging station properly, including all the issues we have discovered just now. Grid integration is also important, how to manage the grid, how to make it stable, how to manage the power demand, V2G technology will be all go into here. Renewable energy will be must. We don't have sufficient power. We don't want to build additional gasoline station. EV is trying to reduce the emission. If you continue to build the thermal generator, like the kind of the coal fire is not making sense. So we need to be using renewable energy. So renewable energy integration will be important. And how we work with the battery swapping, because once we use battery swapping, we can therefore improve the charging time. The battery after swapped, we can slowly to charge the battery in our own facility, our own preferred time. That will also benefit the battery and benefit the whole society. The infrastructure planning will be important. How to design the urban and also outskirt kind of the development to make sure that whole infrastructure can meet with the future demand. But infrastructure highly relate to the incentive and government policy. How the government policy will subsidize the EV, paying less tax, or some kind of the incentive to support the user. I think in the past, many countries, when you buy EV, they will subsidize you a certain amount of money. But of course, not anymore. Today, they only subsidize you with the tax reduction. Technology and innovation. I think today we talk about autonomous vehicle. That will play an important role for all the technology innovation related to the infrastructure. So next important area we talk about for this for last few weeks with battery swapping. We spend quite a lot of time in battery swapping, right? Then we know battery swapping has been promoted since the first day of EV development. Because in the first day of EV development, we know the battery is not capable enough, then we tend to use battery swapping. But however, not very successful for the last 10 years, mainly because of, one example, Better Place, so big company also get bankruptcy. I think mainly because the infrastructure cost is expensive, the limited vehicle compatibility. You need to have all the vehicle compatible to a battery. That is impossible. The battery ownership, we like to own our own battery. We don't like to share the battery anyway. Many people don't like to share, especially car or battery, right? The technology is still a challenge because how to make sure that when you swap battery, the connection, high current connection, you see 100 amp, 200 amp of the battery connection, with a plug and unplug every day, that can be a challenge. That can be really dangerous. Usually the connection, because of the contact problem, we have on fire. Many vehicles, the battery pack have been on fire, not only battery pack, but other companies using battery swapping have a connection point on fire. So that means the market may not welcome at the time. But however, after many years, it seems battery swapping also have some confidence again. That may including many major companies in the US, in Japan, are getting notice. They do have many successful cases. Why is that? Because they now have more flexible ownership model. They do have very good support from the auto company. The infrastructure are much more easy than before. We also have high demand for EV. Sustainability focus are also major thing. We don't like battery because battery is not environment friendly. So that's why we tend to use battery swapping can improve that. We don't need to have big battery in the vehicle. We can also have a high demand for the short charging time. That also making the battery swapping technology could become again. So dynamic charging is also another big topic we discussed just now. I think by dynamic charging, we also looking into can reduce the range anxiety because once we move the vehicle, we continue to charge. We don't have range anxiety, we continue to charge the vehicle. Then in this case, we can reduce all the charging infrastructure. We don't need a big structure everywhere a charger because we can reduce the charging station because we charge the vehicle all the time. So the main usage probably will be the public transport, like the buses or this tram or train will be all important for dynamic charging. At the moment, most of the train are using dynamic charging because we use the overhead line to do that. Many of the city tram are using this method. But what we're looking for will be for private car or buses or for other vehicles. So charge will be, implementation cost will be high. You can see that in the whole city or the whole highway, we have this kind of overhead line or underground wire power transfer line is really expensive, impossible. We don't have standard. Your overhead line or underground line, that standard may not be in other vehicle. So how to collaborate together to build a standard that everybody happy about it is impossible or quite difficult. So that means to move and charge also in terms of power transfer or power technology is not simple job. So the future, it mainly depends on how much investment we get from the government or from other investors. So payment method we have been talking about just now. Payment method, key thing here will be about the pricing. How to determine the pricing? Would that be pay per use or flat rate or time base of the fee of method? But surely the pricing must be dynamic. It vary along the day. We do have some incentive discount to those off-peak users. But security has been a problem. We try to solve this problem all the time, and for that relate to the data protection and fraud prevention. So all these things will be important for to improve our payment method so that we got more experience to improve our security for the payment system. So the opportunity charging is another big issue, right? We need to have a good location for opportunity charging. Usually will be in retail location, shopping mall, parking lot, and also some rest stop, including the stop, terminal, or traffic light. The benefit already discussed mainly about convenience, able to extend the range, and also reduce the anxiety of finding the charging station. And we can also reduce the total number of the parking space or parking level. But however, opportunity charging, sometimes it may include fast charger in a way that may not be a good thing for the battery. But if we design properly, we can use slow charger, but we're putting more charging station, more opportunity charging station. That also be okay. So that all depends on how we're going to design the total system. Next one will be city planning. You see, EV city planning are quite a special topic. Many researchers are looking into this method. So that relate to the smart grid development, relate to the sustainable transportation goal, how different zones using different kind of the policy to do that. We also need a lot of the stakeholders to assist with the EV development, including the business people, residents, and also utility people, how to help us to develop the whole system. Incentive will be important. With government support, tax allowance would be one of the key things to helping the city development with the EV. So, but anyway, I think in the future, we do a really good data collection and adaptation, and also autonomous vehicle development helping this. So finally, I think the power issue of EV we just discussed. We did a tutorial to show you the EV demand anyway. So we know that EV demand is a big thing for whole EV development. So how to make things properly, we do need to have a peak demand management and also the load management. We need to integrate the renewable energy. The whole infrastructure we need to redesign so that we're able to have better planning for private vehicle and also for public vehicle. They need to partnership together to do it properly. We need a really good level, incentive, government support. The whole framework need to be do. At the moment, EV education is not sufficient. We need to improve that. We need to improve the community awareness, how to make them understand the energy efficiency is so important. Even though EV accident is much less than gasoline vehicle by at least 10 times anyway. So there's a lot of improvement. So that means in the future, training education will be important, not only train the public awareness, but also train new engineer, new educator, so that they know what's EV. We need to have more engineer, more teacher, more professor to teach the next generation how to understand design, how to use the EV anyway. So that's an important part for the second half of the lecture. Any question? Okay, that's all for me. And